base of the second glue joint, bringing the tape around 2 to 3 times. This will protect the insertion tube from cutting and nicks, from dremeling or filing. For added protection, you can use ordinary paper towel by wrapping it around the insertion tube below the tape and the glue line. And taping this onto insertion tube. This will also protect insertion tube from any glue that might spill out onto insertion tube. Now we have the glue binding, Scotch tape, and a protective paper towel. We can now proceed to cut into second proximal glue job. Again, with your X-Acto knife, cut halfway diagonally into the second glue job. You'll be cutting halfway into this glue job diagonally. Make an incision halfway into glue joint with X-Acto knife where diagonal has ended. Then you can safely peel back glue without damaging insertion tube. Continue to cut around halfway into the second glue job. And peel off old glue. Cut into bending rubber partially to remove some of the old bending rubber, which will allow us to gain access to the other half of glue joint. Again, using our Dremel tool or file, we will remove a small thin layer of glue from the endoscope without cutting deeply into the insertion tube right above the Scotch tape line. If necessary, turn over the endoscope to be able to have easy access to underneath to file off glue. Be sure when filing off glue to do exactly the same plane as the insertion tube and not to cut any deeper into the insertion tube itself. Again, if you don't have access to a Dremel tool or are uncomfortable using it, use a plain file to file off glue. file the glue all the way up until you meet the Scotch tape mark. Again, be careful not to file down into insertion tube. If you do, you will cut into bindings which will cause threads to pop up, which will make it difficult when it's time to re-glue the bending rubber sheath. Once glue has been completely filed down, we can remove the remainder of the bending rubber by using a good pair of sharp scissors. Insert the blunt end underneath the old bending rubber, which is to be replaced, carefully cutting away towards the distal end. We have carefully cut off the existing bending rubber, which now can be removed, exposing the bending section mesh underneath the bending rubber sheath. Before we can proceed with replacing the bending rubber sheath, be absolutely sure that there is positively no moisture, either water or cleaning fluid, internally in the bending section mesh. The easiest way to do that is to see underneath on a paper towel if you see any moisture. If there is moisture inside the endoscope, it needs to either have a minor or major fluid invasion, which in turn means that the instrument will need to be aerated in a vacuum oven chamber. If you do not have access to the vacuum oven chamber, it will have to be repaired at a repair facility. Since this endoscope and your endoscope is dry and there's absolutely no fluid in the bending section mesh, we can proceed with replacing the bending rubber sheath. This particular scope, an Olympus GIF XQ20, will require a 9.8 millimeter bending rubber sheath. Using a ruler with millimeter markings, we can measure the endoscope from one side to the other side of the bending section. Again, in this particular endoscope, it is a 9.8 millimeter bending rubber sheath which will be required. We will now prepare the 9.8 millimeter bending rubber sheath to apply over the bending section of this Olympus gastroscope. Using a 9.8 millimeter vacuum jig, we will slide in 9.8 millimeter bending rubber sheath, which is particular to this endoscope. We will need to cut the XX bending rubber sheath to be able to apply it over this vacuum jig. Cut and leave approximately 5 millimeters of bending rubber sheath on each end of the vacuum jig. On one end, pull the bending rubber sheath over the vacuum tube. Be sure bending rubber sheath is pulled up and around the end of your vacuum jig. Proceed to the other side. Cut off XX once you've stretched the bending rubber, and again pull the sheath up and over the other end of vacuum jig. Bending rubber is now fit into jig and ready to apply onto endoscope. We will now prepare bending section It is not always necessary, but it can apply a thin coating of molybdenum powder, which is a graphite powder, to the bending section, which allows for less friction against the bending rubber sheath. Again, this is a molybdenum graphite powder. Using your Pliobond, put a thin ring of Pliobond around the bending section at the distal end, but not on the bending section mesh itself. Put the metal for the bending section. With bending rubber inserted into vacuum jig, attached syringe to vacuum jig via tubing. This will apply the vacuum necessary to pull bending rubber into vacuum tube. Carefully slide pressurized vacuum tube with bending rubber over and up until insertion tube joint. Release pressure in syringe. Pull bending rubber out of vacuum tubing. Slide vacuum tube off of bending section. Bending rubber has now been applied onto bending section. Discard paper towel with molybdenum graphite powder if used. We will now bind bending rubber onto fibroscope bending section. First, cut off excess bending rubber, being careful not to cut into insertion tube or distal end. We will now use black silk thread. Cut approximately 12 to 15 inches of thread. First step is to make a loop. Wherein loop approximately 1 inch of thread start with the distal end of endoscope, approximately 4 centimeters from where the distal end hood or CC cover stops, approximately 4 millimeters, holding down loop with thumb onto bending section. Take other end of silk thread and start to loop over initial thread. Turn thread over at least 3 to 4 times. With a pair of needle nose pliers, grab one end of loop and pull very slowly. When pulling the thread, do not pull the end that is underneath your thumb. Feel for the end that will pull underneath the 3 to 4 bindings made. This will be shown in detail in the next illustrated graphic. This is an illustrated representation of applying the thread binding onto bending rubber sheath over bedding section. Again, the first loop will be put underneath thumb, as shown here. You will take your needle nose pliers and pull on one thread until this loop is drawn underneath the threads. You will feel which thread it is most of the time underneath your thumb. Again, find the thread that will pull underneath the 3 to 4 bindings, and you'll pull that until it goes all the way through, but not far enough where you will pull the binding completely out. If you pull the wrong loop, you will pull on the initial thread. This is to be left in place and not pulled through. You will find the thread that pulls underneath the initial 3 to 4 bindings. Once you have pulled the binding through the 3 to 4 turns, we can now continue without holding your fingers over the loop to bind all the way up, right up against the distal end C cover. Once we have reached that point, we can take end of black silk thread, pushing it through the loop, holding it tight. We will pull the end of the thread, which feeds underneath all the new bindings, pulling the loop to the edge of all the bindings. Once that loop or knot is flush up against all the bindings, we will take our needle nose pliers and pull that loop underneath all the bindings approximately halfway. If you pull the loop completely out of the bindings, you will have to repeat the procedure because it should be very tight and right up against the distal end hood. Again, be sure that all these bindings are very tight. This binding should not allow any air to escape from the bending rubber through the bending section. It should be airtight even without the glue covering our bindings. Take your sharp scissors and cut off excess binding thread approximately 1 inch. We will now show you the bending rubber binding sequence again on the second glue joint using a white thread, but be sure to use a black silk thread. Make a loop with your binding thread. Cover the loop with your thumb. Take the longer strand of bending thread and make 3 to 4 turns away from your thumb. I will show you now how to bring the thread underneath your thumb, which should be placed over these two bindings. But in order to show you, I've used white thread and I've taken my thumb off the bindings, which it should be. I will carefully pull on one thread first. This is the thread that goes underneath my thumb and out the back, and that should not be pulled. It will be the other loop that you will pull through. Now the binding has pulled through the 3 or 4 turns. The thread which is run down the scope will stay out the back of your thumb, which should be like this. Your loop is now pointing towards the distal end of the instrument. Now we can proceed to bind at least another 3 to 4 turns. Again, this is using black silk thread. Once we have made the additional 3 to 4 turns, we will pull our thread through the loop again, keeping a good tight grip on your thread without snapping it. We will pull the first set of loop, which will pull flush up to the loops, then pull through halfway, but not all the way, as to untangle your binding. Now your binding is tight with your turns and should be airtight, as not to allow any air to escape from the glue job bending joint. We now have 2 bindings, one at the distal end, right up against the distal end hood or CC cover, and the second where the insertion tube meets the bending section. Again, cut off the excess thread, at least 1 inch. Next, take your thin gauge wire and apply 2 drops of Aran Alpha or Crazy Glue onto the binding itself. This will keep the binding in check so it will not pull away during use and gluing. Do the same for the binding at the distal end. Two to 3 drops of Aran Alpha or Crazy Glue. Once the Aran Alpha or Crazy Glue has dried, we will carefully cut away the binding thread. First at the top, where it meets the distal end, carefully cut flush up to remove the first thread, and being extremely careful as not to cut into the bending rubber, remove the second end. Also, do the same with the thread at the juncture. by cutting flush up against the binding and not cutting into the bending rubber. Now we will remove the excess bending rubber sheath from the tip of the scope, taking a sharp X-Acto knife, change the blade if necessary, find the edge of the black silk thread, and at the last binding insert knife blade and cut around distal end or C cover underneath. Cut completely around the distal end hood. We can now pull off excess bending sheet. If it's still attached, carefully cut to totally remove. We will do the same at the other glue juncture, carefully inserting knife blade at top of bending joint where we have made our previous binding, and cutting between the insertion tube and the binding, not the binding and the bending rubber. Turn instrument over or flip distal end to be able to cut cleanly away the bending rubber sheath. Grab your sharp stainless steel scissors and carefully, without cutting into insertion tube, cut bending rubber up until incision has been made near second binding. We now have a nice clean binding and bending sheath flush up against the distal end or C cover, and a nice tight binding up against the insertion tube and old glue joint. If there is any excess bending rubber, please cut away with knife. If this is not cut clean, when we glue each bending joint and binding, it will poke through the glue. Using a paper towel and alcohol, clean the bending rubber and binding joints to remove any old glue, new bending rubber sheath, and any debris, and most important, fingerprints from the bending rubber, which will make it difficult to make a proper glue binding to our new bending rubber sheath. Using a good quality Scotch tape, we will need to make 3 more Scotch tape loops around the new bending rubber sheath. We already have one originally that we put on insertion tube. we'll need to put 3 more Scotch tape bindings. You can start with the second glue job and approximately 2 millimeters from the binding add another Scotch tape loop. Again, make it only 2 millimeters from your binding. We want to make the smallest glue binding as possible, close enough to the binding and far enough away from it so our epoxy sticks to the insertion tube, the binding, and the new bending rubber sheath. We'll make another Scotch tape loop, again 2 millimeters from our previous binding at the distal end. Curl the tape over so it's easily removed after we have glued the new bending rubber sheath. This allows the tape to be removed easily again once we've glued. And one more Scotch tape loop, again approximately 2 millimeters from the old glue. When we are applying the last Scotch tape loop over the distal end, be sure to cover any holes. These are holes that access the air-water nozzle and image guide lens system. If these are glued over, it will cause difficulties when removing air-water nozzle to clean or replace. We will now mix our bending rubber sheath epoxy. This bending rubber epoxy requires a 1-to-1 ratio when mixing. It is also clear and will require a black pigment. Other epoxies that can be purchased are 2-part epoxy, which requires 60-to-40 ratio, and you will have to add black pigment, or you can purchase an epoxy which already has the black pigment mixed in with the hardener. We will carefully mix epoxy according to manufacturer specifications. Some epoxies can take up to 1 to 2 hours in order to start to set. Once you're used to applying bending rubbers, you may start mixing your glue before starting repair of bending rubber. I will now add a small amount of black pigment to our epoxy. It is advisable to use a class 6 type epoxy. Once our epoxy has set up according to manufacturer specifications, we can glue endoscope bending rubber sheath. Before we glue, we will take our soldering iron hot and we will melt away any loose threads or bending rubber sheath that stick out. Be extremely careful not to melt into bending rubber or bindings that we have made previous. Solder iron will melt away any strands or any debris that sticks out, which will cause the bending rubber glue to have foreign objects sticking out, which cosmetically will spoil the glue job. If you're gluing a fibroscope, it will be necessary to use an ETO cap evacuator. This equalizes the pressure in the endoscope, so when we make a glue binding, bubbles do not form underneath glue. If you're gluing a videoscope, it will not be necessary to equalize the pressure. Reason being is when ETO cap is off electronic connector, the pressure is equalized because air is allowed in and out of endoscope with ETO cap off. We will now apply glue to our bending rubber sheath. First step is to take small amounts of our bending rubber sheath epoxy and fill in the gap first initially between the insertion tube and the bending rubber. Fill in this gap with your epoxy. Turn endoscope over if necessary in order to fill in the entire diameter with epoxy. We will do the same at the distal end. Filling in the gap with our bending rubber epoxy. Turn endoscope over if necessary to fill in the complete diameter 360 degrees around the bending rubber joint to the distal end C cover. At this time, if you notice any objects sticking out of glue, use your soldering iron to heat and melt away any pointed objects that are sticking out of our glue joints. This will save time by removing pieces of debris that might stick through our glue job and spoil it cosmetically. We will start on the lower bending joint. We will now glue it using a small amount on any type of paddle, or you can use a toothpick. Spread out glue entirely around the bending rubber sheath joint. Make it as close as possible to the insertion tube and bending rubber without any objects poking out, such as our binding thread or bending rubber. We want the glue joint to be as thin as possible, so during procedure it is passed through patient without any distress. We will now glue our top binding Carefully hold scope, being conscious of our first glue job